initial velocity in the x direction. It's giving us a velocity now. That's 6.0 actually meters per second. It asks us, where does the climber land? X final. That's what we want to find out. X initial is 0, so where does the climber actually land? Alright. Well, since X and Y components are independent of each other, he falls at exactly the same rate. He falls vertically at the same rate as he would in the first part right there. So he has exactly the same amount of time to move horizontally. Time is 0.75 seconds because he's still falling 2.75 meters vertically. So that gives him 0.75 seconds to move horizontally at this new velocity. So if velocity equals displacement over time, we can solve for displacement by saying the displacement is going to be velocity times time times time. Okay. Now here I wrote delta x with a change in x, and I said we're solving for x final, but really it's going to be the same thing because our initial x is 0 anyway, so x final or delta x will be the same thing. But what is that? You know what, I'll just write it as x final because we want to actually use that for something else. X final equals initial velocity 6 meters per second times time 0.75 seconds, and our final position, final x position, moving at that velocity, is going to be 4.5 meters. Because that's not really what it's asking us. It says how far past the edge, or B, it says where does a climber land? Okay, well, if he has to cover 4.10 meters and he covers 4.5 meters, 4.5 minus 4.10, that means the climber lands, and yes, 0.4 meters past the edge. It's really just a matter of reading it. This is really our answer as the question is asked. So that's B, where does the climber land? And part C, what is the climber's speed and direction of motion when landing? Okay. Well, we know one part of this already. Now remember what this is asking for here is the resultant, you might say, or the v final, of the vector, the final vector of his velocity. So it's a combination of x and y components. That's what we want to find. Well, we know the x because in these second parts, B and C, v in the x direction is 6.0 meters per second. And it's not going to change because there's no acceleration in the x direction. But we want to find initial velocity, or sorry, final velocity in the y direction. Okay, what is that? We want to find that so we can combine these two together using the Pythagorean and get our v final. Well, our velocity final in the y direction equals velocity initial in the y direction plus acceleration in the y direction times time. Alright, well, our velocity final in the y direction, what's the initial velocity in the y direction? 0, right? Well, that's easy. Plus negative 9.81. That's our acceleration in the y direction. And our time is the same amount of time as before because he's falling the same distance, 0.75 seconds. All right, so negative 9.81 times 0.75 seconds, that is negative 7.36 meters per second. And that makes sense because the y velocity started at 0 and he's falling downward, so of course we're going to have a negative velocity now after. So we have, well, I shouldn't have boxed them because that's not our final answer, but that's the x, and that's our y value right there, and we know what to do with that to solve for the resultant. The resultant, that is the magnitude of the final velocity. That's the square root of what? 6.0 squared plus negative 7.36 squared. Punch it into your calculator. That gives you 9.5 meters per second. Okay, that's the magnitude of his direction when, that's the magnitude of his velocity when landing. The combination of x and y components. And what's the direction? Well, the direction theta is the inverse tangent of the y component, 7.36, over the x component, 6.0. It comes out to be 51 degrees. And if you really want to split hairs, we might say south of east. South of east, because it's got a negative y component right here, and it's got a positive x component. So it's south of east or below the positive x-axis. There you have it. That was kind of a long problem right there, but I hope that broken down it makes a little more sense to you, and you see these as chunks of things that you can do rather than one big impossible problem to solve, because of course they aren't impossible. You just need to break them down and do them procedurally. So again, I hope that helps, and I'll see you on the next one.